Hello everyone, I'm Pertti Peussa, managing this webinar about electric buses, and I would like to first welcome you all on board. We have interesting presentations, especially about how a longer term usage of buses with new energy sources, especially electricity, what kind of findings there are. Some of them are expected ones, and some of them may be a little bit surprising. However, this webinar will contain many presentations, and therefore I wish that the presenters would be able to maintain the time period reserved for them, so that we have time for the end of this webinar where questions and answers are all carried out simultaneously for these presentations. So there is only one questions and answers stage in this webinar. First, I would like to welcome Gorain Zoltan, who holds the degree of Technical Sciences and has been very active in energetic ICT and services over 20 years in Cluj metropolitan area, where he has been actively involved in the implementation of many kind of projects, but also including sustainable urban and mobility plan projects. Please, Zoltan, have the floor.
Thank you very much. Hello, everyone. As I was presented, thank you for the beautiful presentation. I'm the manager of the Cluj metropolitan area. A few words about Cluj metropolitan area. Cluj is the second city of Romania. It's situated in the northwestern part of Romania. And our association, the Metropolitan Area Association, is comprised of 20 municipalities, Cluj-Napoca, and 19 communes near Cluj-Napoca. We had a population of about 411,000 inhabitants on paper. In reality, we are over 500,000 people, and among these, we have about 80,000 students during the school period. We are active for about 15 years and are involved in all the strategies regarding the development of the metropolitan area, trying to coordinate the development of different municipalities and to make the projects work together. Today, I will present you our results regarding the sustainable urban mobility and on focus with the electrification of our public transportation network. When we started this project in 2018, as I suppose, as I remember well, we were in Tampere and seen in Tampere a few electric buses. Back then in 2018, Cluj just ordered the first 11 electric buses. Meantime, in those 5 years, the whole area developed a lot. Now we have a strategy to achieve until 2026 100% electric public transportation, and we invested already 100 million euros in the electric public transportation fleet. Until now, we use 41 electric buses, and my presentation will be about those electric buses. We also use 90 trolley buses and about 18 trams, electric trams. We are using our availability of electric buses is about 90 to 93%. Usually we use 38 from those 41 buses on a daily basis. 3 of them are on maintenance and on reserve stock. They are used on rotation. Now we have about 52% of the transported passengers in electric means in Cluj-Napoca, and we have the biggest electric transportation fleet in the big cities from Romania. As I said, our goal is that to achieve until 2026 100% non-internal combustion engine transportation, and I will talk you later about what this means. We are now in procedures to buy 40 more electric buses of 18 meters. Until now, we have just 12-meter buses, and also to build new fast charging stations exclusively for bus fleet, because one of the gaps, one of the challenges, one of the problems is regarding the charging station for those. Also, we started to develop a metro and underground metro system. So it will not be ready until 2026, but it will also means to transform the transportation system totally to be electrical. Until now, we use Solaris buses, 12 meters electric buses with a capacity of 78 passengers, 27 on seats, 51 standing. On the paper, they have an autonomy of 105 kilometers for new batteries. They have 200 kilowatt hours batteries and 100 kilowatt, 220 horsepower electric engines. They are fully lowered floor buses with ramp chairs for wheelchair and for disabled people. We have no spaces until now for bicycles. We have just external supports for 2 bicycles on each bus, and they are usually used in the when it's not rainy or a snowy period. We had a lot of challenges. As I told you, we started with 11 buses from the first generation to see how they work and how they compare with the specification the producer said. We realized that in summer and winter period, the autonomy is lower with 20–30% because the heating or the air conditioning system. We also had problems with the first generation of batteries because they are not wear off uniformly. So the battery packs in the buses, some batteries wear more than others, and now we started to equilibrate those by intelligent charging using the charging stations. We also had in the beginning some compatibility issues with charging stations and with fast charging stations. As I said, they had lower autonomy than we expected. We are trying to overcome those, and also the later shipments, the later buses had better battery usage, better autonomy. The maintenance issues are related just regarding the terms of the spare parts. From technical point of view, they are easier to maintain than the old internal combustion engine buses. Their availability is higher, is more bigger than for the classical internal combustion engine buses. Even if also the old fleet is all Euro 6 buses, not older than 6 or 7 years. Still, the maintenance issues are far less for the electrical fleet than for the conventional fleet. Other challenges are lack of empirical data considering the effectiveness of the existing public transportation infrastructure. We had no, let's say, very scientific measures, scientific feedback of those buses. We rely on opinion of the citizens and the municipality department of the municipality. We're trying
Zoltan,
to.
I think
Yes.
we lost your slides. If you can.
I have full screen. I seen my slide. I don't know. I have full screen. You didn't see.
It disappeared a few minutes ago.
I changed nothing for the moderator, please, because the moderator allowed me for the beginning to show my presentation. Okay, it's back.
It's back. Yes.
Okay. I think somebody must have pressed on the wrong button. It's just come back now.
Okay, so we were here somewhere. Yes. Okay. Thank you. One of the other issues are that the sustainable urban mobility planning make just recommendations for the projects. We as the Metropolitan Association, we are responsible for the urban mobility planning, but we can make just recommendations. The projects and the implementations are in the responsibility of the Cluj municipality, but they act in the directions we are foreseeing, but the speed of implementing the projects are not so fast as we assumed in the urban mobility planning. The biggest challenge from my point of view, because I am working with all the companies, all the entities, and the whole infrastructure, are regarding the energy requirements, regarding the charging stations, because in some specific hours when the buses are returning to the charging stations after the rush hours, the energy infrastructure doesn't can deliver enough energy to for all the fast charging stations, and that's why the next 6 fast charging stations will be also combined with a new energy network to don't have this problem and to can fully charge very quickly the buses. As I said, from the current European funding period, we will buy new 40 pieces of electric buses, but in the next future, this 40 will be the last electric buses, 80 meters long, but in the future, we will change the technology to hydrogen fuel cells electric buses. And after those 40 fully electric buses, we will change and we'll try to use just hydrogen buses. That's why I said that we will not use any more internal combustion engine buses, but not classical electric, but hydrogen buses. We want to change on the middle term period the fleet to hydrogen buses because probably the autonomy and the availability during the day will be will be better than we have now with the electric buses. In the same time, we also are using different other projects regarding the infrastructure and the communication to the population regarding the usage of electric transportation. We have dedicated lanes toward the old city. The whole city, also these lanes increased the battery life and the autonomy of the buses with about 10% because they are not staying so much in traffic, just using electricity for heating or for air conditioning. And the autonomy increased about 10% when they are using dedicated lanes. Not at municipality until last year, just at the municipality level, but from last year also at metropolitan area, we have so-called Green Fridays, when the whole public transportation in the metropolitan area is free for everyone for each passenger. We have some smaller projects like health tickets. We have one ticket station where if you are doing 20 knee bends in front of the camera, you will get a free ride, a free ticket. A lot of people are using this because it's for free and they are going there to get their tickets, 1 ticket per day per person. It's very used, and the population was very happy about this initiative. Also, we have free public transportation for retired pupils and students, and also we have for the schools dedicated school buses, which now are internal combustion buses, but we try to in the near future to change also those dedicated buses to electrical fleet.
Thank you. That sounds
this
very
was
good.
Very short.
Development. Yes.
Okay, 10 minutes, and I'm waiting for your for your questions, and I hope that I can answer your questions. Thank you very much.
Yes, we will reserve this period for the end of this webinar. And this knee bend access to the buses is very interesting, especially if you have well-working feet, so you can really earn with them. Okay, let's continue our European journey. The next city we are focusing on is Pamplona, and we are hearing first about the overview of this experience from Julie Farré from Moventia, and after that, well, let's start, Julia, and when you transfer to Gabriel, I will introduce him very briefly, unless you have considered some very smooth transition.
No, I think we'll do first I start because I do a bit of context, and then he can do his part.
Fill in the bits and pieces, and please try to stick to this approximately 10-minute time zone.
So
thank you.
Can I gain control? No, I think I can show my screen.
Yes.
Let me see. I haven't checked it. Can you see? Let me just. Can you see it?
Yes.
Okay, perfect. Wait. So back to this. Let me. Okay. So thank you, and okay. How can I do it? Yes. So I'm gonna do a brief overview of the experience that we had in Pamplona as the operators of the urban bus contract. Our client is the Mancomunidad de Pamplona, and we are operating this service for more or less 12 years. Right now, just renewed the tender, so very happy. And one of the pilots or let's say tests that we do in the context of this contract was the introduction of fast charging. That was back in 2018, and I'm going to briefly describe the key aspects of that test, of that project. First, a bit of definition and the first steps, a bit of focus on the administrative procedures that we had to face, how was the execution of the works, launch and operations, what needed to be adjusted afterwards, because there were some things that went differently than what we expected, and a bit of future look into our commitment to, together with Pamplona, to new technologies. So a bit of context, the urban contract of Pamplona is giving service to around 340,000 inhabitants. This means the municipality of Pamplona plus 17 municipalities more, so it's a bit of interurban contract somehow. We are managing 34 business lines with around 160 buses, and we are, sorry, because I have this in the middle of the screen, and we have around 135,000 users a day. So again, we started this kind of pilot or experience in 2018 together with the Mancomunidad. The first thing was to choose between all the lines that we were doing, which one would be more suitable. The Mancomunidad actually chose one of the lines that is very eccentric. It crosses the city more or less by the center, which is the line 9. It's a line that goes from a rail station to a university, which is quite crowded at peak hours. Has a distance of 6.5 kilometers, average time around half an hour, and it can reach maximum speed of around 38 kilometers per hour and an average speed not even 12 kilometers per hour. And it's serving an elevation, a difference of altitudes of 46 meters. All these are important parameters, of course, for setting the fast charging system. First thing we had to do was to launch an internal tender to select the suppliers for the solution. So that means the solution would be the vehicle, plus the charging points, in this case the pantographs, plus the full maintenance of this system, both the charging points and the vehicle. The choice at that time was fast charging, because in 2019 we could not find in the market a slow charging mechanism that could keep the bus for 16 hours of continued service, which was needed for the KPIs that we have for the contract with the municipality. So we had to go for fast charging. The winner of the tender was Vectia, which had a 100% electrical bus, having a backup diesel engine that worked as a generator in case of the battery problem or shortage. The main parameters, very schematic. What were the key things that we had to put in that tender for the suppliers? It was based, of course, on what the market could offer, but as well on the line 9 specifics. So we had a maximum charging time of 3.5 minutes, minimum autonomy of 8-9 kilometers, a bit more than one way, but at the end it could reach almost 10. We could even do both ways as well, but our requirement was at least 8-9. And then, of course, number of charging points. It was needed to have one at each both ends of the line. So,
Julia, do you have more slides? I was just a bit worried about Gabriel's time slot.
Okay. You want me to go fast?
Yes, please.
Yes. So these were the main parameters, and the charging, the power of 300 kilowatt, of course. Bit of administrative procedures, just to say that this was actually the bottleneck of the process. So we were very worried about technical things, but at the end, what was more tricky was the license cost, authorizations, taxes, all the negotiation with the municipality and the university to put the charging points and the power supply stations. This was what took more time. In terms of the execution, this was 6 months. So from the supplier contract award until the start of operations. But there were no big surprises in the execution. So just one of the charging points was very direct because it was low voltage. It was the rail area, very easy. And in the university area, we need to transform the voltage from mid to low tension because it was not available. But all this was done within time. In terms of launch, again, the critical path was the reception of the pantograph and the discussion on where exactly the station had to be placed. A bit of political and legal aspects, but in terms of technical issues, there were no technical big problems. 6 buses were needed to cope with the service, and then again, as I said, the later adjustments that we had to do in terms of conclusions of things that were differently. So mainly on the technical parameters, instead of 300 kilowatts, we used 200. The charging time actually was increased by 1.5 minutes. So it was longer, which sometimes could endanger our punctuality. And the autonomy was more than initially prescribed. So we could actually, at the end, perform the two-way trip, as I said before. And just a bit of like a summary, our commitment to the new technology. So in Pamplona, we've been since 2011, we've been trying more or less everything. First, there was the first regular line, urban regular line in Europe, La Pilavesa. That was the first check. In 2013, we started the first hybrid experience. 2016, we started with gas. The bus was running with gas. And in 2019, it was this line that I explained. And in 22, we started with natural compressed gas with the origin, renewable origin. And this year, we started with the with the slow charging for a lot of 20 buses in the network. So thank you. That was more or less it. I hope it was clear. If there are any questions, feel free to.
Yes, the questions could be carried out and discussed at the latter half of the webinar. Thank you, Julia. The
Sure.
next speaker, I'm in a bit hurry here, is Gabriel Garcia Naveda, who holds a degree in industrial engineering, and his main activities are related to R&D in energy storage as well as electric vehicles. And he has also participated in projects concerning energy management systems. And let's go to his presentation about the follow-up of Pamplona buses.
So thank you very much, Bertie and Julia, and good morning, everyone. I would like to share my screen. Maybe, Bertie, you need to help me now.
I think there's this. Yes, now it looks promising.
Okay.
And even more promising.
And this is it. Okay, so today I'm talking about the monitoring platform that we develop within the activities of the Stardust project for this, for the monitoring of the operation of these 6 electric buses that Julia just told us about.
Yes, and I was wondering, sorry to say, if you could be able to do this in 6-7 minutes.
Okay, I'll do it fast. Yeah, as Julia told us, it's 100% electric traction using the regenerative brake and backup diesel engine for emergency purposes. There are moderate slopes in this 6 kilometers route of the bus. And our task here and our work that I'm presenting was to gather all these different sources of information. The main one from the monitoring system on board of the bus, but also some other information that the operator sent via CSV files and different types of data needed to be coordinated and with different granularities and so on. So this was in the end the result, where you can easily change the time frame you want to make the consultation, the different screens you have, the 6 units of buses. You can see the information aggregated of unit by unit. Some other information is shown in tables, like the incidences of bus and pantographs. And this is the main screens where the data is everything joined and shown. Energy balance, economic balance, the incidents, everyday events, the operation of the buses, all the details about distance, time, and so on. Battery operation, what was one of the main concerns for us to verify that it worked as expected, and the operation of the pantographs. Sorry, I'm seeing the little screen. So these are some examples of how the information is depicted. Here we can see the breakdown of the energy sources. For instance, with the time of the operation of the pantograph, all data can be easily exported if you want to work with it in some other different platform. This information, for instance, is with a breakdown per bus, so you can see all of them together or one by one. And other figures, for instance, can show this average consumption per 100 kilometers and so on. So we had to interpret all the data, make some calculations, and try to show everything in the easiest way for the operator and for the municipality to get the conclusions and to see that this electric bus line was working as expected. Here we can see some other information, for instance, for the battery, accumulated cycles from the beginning, from 2019, almost 5 years, and they experienced around something more than 10,000 cycles, which is a lot for the batteries, but they are performing very well. The distribution of the temperatures along the years, and so they can study how summer and winter impact on the operation of the bus and in the battery. And this is an example of the distribution of the speed of one bus during one specific day. So with this information is very valuable for them, and they can get these kind of conclusions, how with the number of passengers in the evolution here, for instance, during the pandemic, the distribution of the temperatures along the different seasons. And last of my presentation is this one about the battery. The battery was dimensioned to operate normally in a journey using 20% of the state of charge. As Julia said, it also can during weekends where one of the charging stations is not operating, the bus is able to do the 2 routes with just one charge, like this one. And this is an example of a figure where they calculate how much the battery discharges in a normal route, going and return. So one is the blue, and the other is orange, and in average is around between 20 and 25% as expected. So it's working well, and I think they are taking valuable information from this monitoring platform. And this is it. I think I did it more or less in the time.
It was very interesting content. Thank you. If you did something in a hurry, we really didn't see it. At least I didn't. So
Okay.
You obviously have collected a lot of useful information, and I suppose this collection in some form continues.
Yeah, of course. This is a live experience, a live platform, and it's working well. We're continuing with the maintenance, and so they can use it every day.
Very good. Our European round trip, thank you, Pamplona, continues towards Nordic countries to Tampere in Finland, where Marko Paakkinen and Seppo Rantala are describing the results and conclusions from the Tampere electric bus experiment. Marko is a senior scientist at VTT working in the electromobility team, and his current research interests include vehicle charging, especially in megawatt level, and how the techno-economic implementation can be carried out. And I think to save time, I think we let Marko take the floor. Please, Marko.
Okay, thanks. Just checking quickly that I am sharing the right screen, so you are seeing my full screen presentation.
Yes, electric buses in winter conditions.
Excellent, thank you. So, yeah, I'm telling you briefly about the generalized experiences of using the electric buses in winter conditions, and this is based on the experiences gained in the pilot that was performed in the city of Tampere, Finland. The pilot started in 2016 and ended in 2021. So the city carried this out by leasing 4 battery electric buses and a 300 kilowatt opportunity charging station from Solaris. So the buses were basically the same as in Cluj, but the charging was a little bit differently organized. The buses had batteries optimized for fast charging, so they had LTO batteries, 75 kilowatt hours, so much smaller than in Cluj. So these needed to be charged at every round in the line where they were used. And there was only one opportunity charging station installed in the pilot line. That was number 2, as you can see in the image here. And then in addition to that, the buses were overnight charged at the depot with 20 kilowatts depot chargers. But since 2021, when the leasing deal ended, this pilot line has now been decommissioned, and nowadays, let's say all of the electric buses operating in the Tampere region are nowadays depot charged. But yeah, so first good news, electric buses do work in winter if you really carefully consider all the aspects that affect the operation in the winter times. And this is really a systemic challenge. So you need to consider the whole system, including the buses, the batteries, the charging, operating, etc. The main influencing factor is the increased energy consumption that is affecting, again, all the parts in the system. When your energy consumption increases quite much, you need to have either a bigger battery or you need the faster charging, and charging times can be longer, etc. But I won't be telling anything about the numbers. Seppo, who will have a presentation after me, will be telling about the monitoring results. First, the traction energy use. The road surface has a big effect on the rolling resistance. Thinking about the vehicle driving resistances, the air resistance is not very big effect in urban environment, but the rolling resistance, especially slush, seems to be very much the biggest affecting factor in relation to the rolling resistance. So slush, water, snow on the road surface, it increases the traction energy use. Another factor is the bus load, so the number of passengers. There can be seasonal variation, like in bad weather, people tend to take the bus rather than walk or take the bicycle. So that can further increase the energy use in severe weather. And the low temperature in itself is actually affecting the battery capacity, that how much energy you get out of the battery. So you need to have a proper thermal management in the battery. But one effect that actually is quite important, but which can only be affected by proper training, is the driving behavior. The driver actually can affect a lot to the bus energy consumption. The cabin heating is another factor that has a big impact in the Nordic conditions when we are going to -15, -20 degrees Celsius. So the heating needs, of course, increase dramatically. In Tampere, there was a hybrid heating system in the buses, which included a fuel heater combined with an electric heater, and that was adjusted over time. The operation was adjusted over time. Initially, the operator was able to choose that which heating system they prefer, but then the operators tended to pick the fuel heater. So that was later changed, so that it will only start at -15 degrees to save the battery energy, because with the resistive heater, the consumption increases quite much when the temperature goes down. The modern buses typically have heat pumps, but typically these also will need supplemental resistive or fuel heaters in very low temperatures, because then the heat pump COP value goes too low to effectively produce enough heat to heat the cabin. And the number of passengers here has multiple effects. So the more passengers you have, the more kind of heat produced by the passengers you have, but then also more door openings you have that will dissipate the heat. So that's also an interesting aspect here. And one thing that very greatly affects this cabin energy consumption is preconditioning the buses before departure. So that was done in the Tampere pilot at the depots. Charging is heavily affected too. Cold batteries can slow down at least the initial opportunity charging before the battery has heated up. So battery preheating also helps here. Additional energy consumption in the winter means also longer charging times if the system is sized so that you will need many charging sessions over the time. But one thing that is shown in this picture here is that the weather conditions also pose interesting challenges, like snow buildup on charging points. This was causing issues in Tampere with the pantograph charging when there were kind of ridges of snow that accumulated on the driving tracks, and that was causing misalignment with the pantograph and the opposing part in the mast. And to overcome this, the city of Tampere actually installed a heating system to melt the snow around the charging point. And also the one other thing was here that they needed to do was to reinforce the ground, because always driving very accurately the same tracks led to that the ground wasn't supporting enough, so that needed reinforcement too. So the charging point construction to withstand the climate is important, especially in opportunity charging. Then my final slide, how to mitigate these winter effects. So I think that the main thing is to take into account the increased energy consumption over the whole bus lifetime and have proper safety margins there. So you need to also consider the battery degradation over time, and that even at the end of the bus procurement time or tendering period, you will still have enough battery capacity to run the daily operation, and also have safety margins for extreme events, like when you have extreme snowfall or extreme cold, that you can still operate without running out of battery or needing replacement buses there. Preconditioning the buses at depots has a big effect, and then proper design of charging infra. If you need the opportunity charging, then that is very, very key to be able to run the operations reliably. And training was one thing that the PTO raised here during the pilot, that they were really seeing that they would have benefited much more, much from a more comprehensive training for all the participants, including the drivers, but also mechanics and all the stakeholders. So that was my very quick summary, and I'll let Seppo tell you more about the numbers now. Thank you.
Yes, thank you, Seppo. While you are setting up the slide set, just some basic information. You are a senior scientist at VTT, over 30 years of experience in data analysis, software engineering, and has designed several software systems and signal analysis algorithms with MATLAB, Simulink, LabVIEW, etc., etc. But now we will hear how Seppo has been collecting the data and making conclusions out of them. So whenever, Seppo, you feel available, please start your presentation.
Thank you. Can you see my presentation?
Only black. We seem to see something because we see the icons on the lower part of the screen, but the presentation itself is totally black.
Okay, it is wrong.
For the rest of the audience, just an information, at least I am more familiar with Zoom or Teams, so some practicalities with this GoToWebinar is lacking from my side at least.
How about now?
Yes.
Okay, that's good. Yeah, I will first tell some background information about the.
And can you squeeze it in 5 minutes?
Okay, yeah, thanks. And we, as Marco told, there were 4 battery electric buses and 1 hybrid buses, but only the analysis was done for the battery electric buses. And unfortunately, there were only some information available. So there were no information about the distribution of energy consumed, like how much energy is going to the traction motor and other parts. But if we think about the system as a whole, it matters how much battery energy is available. And also there were no information about the number of passengers. So I have used the door status for estimating how many people are, or how much traffic is going from the doors. So those are the values which are used for the analysis. And the monitoring period started 2018, but there were some problems with data, and so the actual period started 2019 and ended August 2024. And there is some information about temperature during that day, during that time, and unfortunately, winter 2020 was extremely mild. There were no much snow and not very cold temperature, but luckily winter 2021 was rather cold, but not much cold temperature. As you can see here, there were much snow. Yeah, the analysis line was rather short one, and it was in the center of city. So there were different kind of situation, and unfortunately there were some changes to the road since it was Tampere was building a tram that day, and also if I think about the analysis of results, COVID decreased the passengers number, so it's not possible to compare some data, but we got some interesting results. And here is the energy consumption for all the data collected from all those electric buses. And as you can see that the minimum is near 15 degrees of Celsius, and also the variance is rather small, that bit after 15 degree. And interesting is that the variance is very large when the temperature is near 0 degree, and from this one it is possible to see that there is much variation also for very cold temperatures. And as Marko told that there was some changes during the monitor period for cabin heating, and that of course changed some results.
Okay, can you go forward?
Yeah, and from the previous slide, it is possible to see that there were some two outliers groups. The first one was high consumption near 0 degrees, and it seems that as Marco told, that slush can or also slippery roads increase the consumption very much. Also, if it is that kind of weather, there is much more people using public transport, and it was possible to see that also doors were open much more than some other days. So it must be taken into account that when the weather is that kind of, it's buses need more energy. And then it was other outlier group is those very small consumption, although it is considerable frost. And from the graph on the right side, bottom of it is possible to see that this is the bus is starting its driving, and it seems this is when temperature is -6 degrees, and when the bus is starting this road, it seems that it is cold, and it has used much energy for heating. But since this is a public holiday day, there is not much people traveling, and so after the heat, the cabin is heated, it needs much less energy for traveling.
Well, thank you. I'm a little bit worried about the time and how much we have.
Yeah,
left.
This is the last one.
Okay, and, please leave that table on the screen, and I think we could already now, thank you Seppo, initiate the questions and answers discussion. So anyone from audience with a question, please step forward. Well, there is one question in the chat. What are the benefits of the fast charging concept versus the overnight charge? I'm not sure to who this is addressed to, but I suppose the one who seems to have the most available knowledge could respond first.
Well, I can jump in. I think the bus operator in Pamplona told us, Julia Farrer told us, that it was an opportunity to buy these 6 buses with fast charge that allowed these 6 kilometers of the route on a single charge, because otherwise the market in 2019 probably was not prepared to have a full day operating, or the weight of the battery would be too much, and the cost, of course, since well, in these last 5 years, the batteries have evolved a lot, both in cost and performance, cycle life, and so on. So I think it was a good opportunity. Maybe today the solution would not be the same. I don't know if you can, the rest of panelists can confirm this.
Yeah, I would agree with Gabriel about this, that during the time that I think that all of our 3 pilots have studied, the battery costs were one prohibiting factor, that you would have the same size battery that you can nowadays get for a full day operation for the bus would have been out of reach. So that has changed quite a lot. Nowadays the depot charging is much more common, but there are still situations like very heavy trunk lines where you still need opportunity charging, and that is like in the Helsinki region in Finland. That is now split, so that the heavy trunk lines are using the fast charging, and then shorter supplemental lines or connecting lines, they are using depot charging. But there are varying business models between the PTOs.
Thank you. Are there other questions? There is also in the chat, there's 3 questions, but they are all about the same. So I think that was responded. Are there other questions? And please, I think you can use your you can also talk loud, I suppose. If not, please write to the chat. We have time for 1 question. Well, I have 1 question which could be responded with very brief comments. During the follow-up period, there were some major differences in the environment where you were operating. For instance, COVID was affecting everyone, and I suppose in some cities there were some heavy gravel transportation periods due to heavy construction operations which were involving with the public transport line fluency. So how do you see how stable is the city in the future, and how do you accommodate these changes when you want to get comparable results over time? I know this is a tough question, but maybe it was a too tough question. I think I will be moving on to the conclusions in order to keep the pace of the scheduled time. So some conclusions were that in some locations the charging infrastructure also needs some attention, not only individual buses, but the overall result to the electricity supply, and also operation with hydrogen or other advanced fuels is something to consider. I saw in Pamplona that over 10,000 charging cycles were carried out without any issues, which sounds good to me. And the overall presentation of the cold environment and small details of the electric vehicle operation sounded quite interesting, especially this, how the inclined bus affects the pantograph operations, and route changes change how the summary figures are changing because the route is going different ways. Are there other conclusions that the speakers would like to draw.
Yeah, I'll just jump in there. I think there are a couple of questions that have come up in the question, not in the chat, but they might arrive in the question folder.
Yes.
I can only read a bit because I don't know, there's a problem with my screen. I can't read the whole of it, but I can see that there's 2 or 3 questions in the questions section. So I don't know whether you can read them, okay?
I could read them as well. I managed to get the whole question visible. So from Tampere, there is a question: are electric buses still viable, or what fuel do you think buses will run on in the future? I think very brief comments from all 3 cities would be preferred.
Okay, if I may start to answer. Our vision in Cluj is to use electric buses. Yes, they are viable, but we are going to hydrogen because we intend to build also solar power stations. We already have solar power stations, and we want to use the production to produce hydrogen, and also to produce hydrogen during the night time when the electricity is available and is cheaper. And that's how we try to use the available resources from the energetic system to drive our public transportation fleet. Just with batteries, it will not be a long-term solution.
Thank you. Any comments from Pamplona to complement this question?
Well, I think in Pamplona specifically, they are moving out from diesel. They are now incorporating new electric buses, but not only, they are also going for hybrid gas engine vehicles. But it's not, of course, just an economic option, decision. It's environmentally and because of the pollution locally. And yes, I think this is the main driver now, to try to get out of diesel in the next years. So little by little, they are substituting the buses with new technologies.
Okay. Any comments from Marco or Seppo? Complementary ones.
Yeah, well, I can maybe answer on my behalf. If we are looking a little bit broader, like in the situation in Finland, I think that the situation is looking to favor quite heavily the battery electric buses, because the market share in urban city buses is closing to 100. So it's very much already transitioning to battery electric. There's been some discussion about hydrogen, but at the moment the total cost of ownership is not really favoring that option because of the hydrogen price. But we'll see what happens in the future. But at the moment, it looks like that the market is favoring the battery electric option quite heavily in Finland.
Thank you. I go directly to the next question, which says, does opportunity charging damage the battery more than the depot or slow charging? Maybe we can go the same pace as previously, so if Cluj can start, then Pamplona will be the next. So the question was about quick charging versus slow charging.
Okay, for the first generation of batteries, for the first buses, yes, they, let's say, not damage the batteries, but decrease their lifetime. But for the last shipments, for the new batteries, they are not anymore an issue, from my information.
Okay, then the Pamplona comment.
Well, as told in the presentation, no issues, no special issues were experienced. The thing was that the manufacturer selected a specific case of a specific technology of battery, which allows a higher number of cycles, but being more expensive. And probably as being one of the first experiences, they oversized the battery. So it's working very nice. Probably now they could size the battery a bit smaller, but yeah, yes, this is working, and as we
so in your response, in your experience, you haven't seen any big issues here, but that's mainly because the battery was originally selected for
probably the specific
support high number of
and size.
Yeah. And finally, if Marco can conclude complementary things, what you think?
Yeah, sure. So yeah, as let's say rule of thumb, the fast charging is more stressing to the battery, but there are many factors that are affecting that, like the C rate at which you are charging, and the battery technology. Like Gabriel was saying that they had a specific chemistry for that. Same thing was in Tampere. That the buses were using the LTO chemistry, which can withstand high C rate charging with very high cycle life at the same time. So it depends on the choices quite a lot, and also the depth of discharge that you are using from the battery. So there are many factors affecting that. So there's not that we can generalize this too much.
Yes, usually that's the way, that when you want a simple answer, you need to cut the corners, and the answer is not good. So going into the operational features, into more details, is probably giving you better answers than simple yes or no. I think I have to thank the presenters, the organizers, and most of all the audience. We have extended our presentation for about 7 minutes, so thank you for your patience, and hopefully this recording will remind you something which you forgot to write down during the presentations. But thank you for all, and let's go.